We are officially recording. Okay, so this idea today, you guys, we're talking about this concept called continuity. And we're talking about continuity of a point and at an open interval. But this whole idea of this thing called continuity. For some reason, I page 29. Okay, so continuity function, what does it mean to be continuous? That's this word, continuous or continuity. And what we're going to have over the next few days here, if you look at the calendar, there's going to be 2 quizzes coming up. One that's a quiz just on continuity, and it literally is going to be memorizing this definition of continuity that you see here. Okay, this definition, right? It's going to be memorizing that word for word and then doing one problem applying that definition, okay? And that's it. It's a quick, 5-minute quiz that just will be nice and brief, but I think it's on Friday, I want to say. So you've got a couple days to memorize this. Next week, there's another one called intermediate value theorem, very similar. You're going to memorize the theorem word for word, like letter for letter, symbol for symbol, exactly as it is, and then do one problem applying the theorem, okay? That'll come up next week, towards the middle of the week. And then that's it in terms of quizzes, and then we get ready for the big test on Chapter 1, which is the following week after that. Question?
Are those quizzes with the memorizing?
Yep.
Is it with a lot of points?
Not at all. It's very, very few points. Yeah, I mean, it's just memorize and do one problem. I want to say 6 points each, 3 points for the memorizing, 3 points for the problem. So it's like nothing. It's really just, I mean, it's not for your grade, it's just for you to know it. These 2 definitions, though, they do come up next year. They could come up on the AP test, so that's why it is something that you need to know how to do. All right, so basically the definition of continuity is kind of like what you would think. So a function is continuous if it continues the whole time. That makes sense, right? The word continue, we know what the word continuous means, we know what continuity means, that's all that it is. Now they're going to go into this big crazy definition of it, but really for what you need to grasp your brain around and get the concept is the function continuous? So what it can't have are these things like holes, right, like the first one. It can't have this thing which we call a break or a gap in the function. And this would be another sort of a gap or a jump. So we've got jumps and gaps and breaks. So anything with these sort of missing parts, these would be considered not continuous, okay? So here it says holes, jumps, gaps, and breaks. So notice these are all just examples of different graphs where we have holes and jumps and breaks. And so these issues here, why are they not continuous? Well, they're not continuous because there's a hole or there's a break or there's a gap, right? It doesn't just continue all the way. Well, in terms of definitions, why is it not continuous? Because we have a value here where it's undefined. That's one reason why we are not continuous, and that's just an example of a hole. We have an example here where a limit doesn't exist, right? I'm approaching one value from the left and a different value from the right. That's called a jump or a gap in our graph, right? And that limit does not exist. That's another reason why we couldn't have continuity. Another reason why we don't have continuity is that the limit exists. It's equal to a certain value, like my limit is whatever this L is here, right? But the actual value of my function is some other y value, right? And that those two are not the same. So that your limit does not equal the value of your function. And so when those two are not the same, and again, this is what we call a break or a jump or a break or a gap. And this would be not continuous as well. Okay, so that's where we get our official definition. And this is what you need to memorize word for word. Just the first part. Okay, and so you need to memorize this whole thing up here. Okay, so a function f is continuous at c if the following 3 conditions are met. So number 1, f of c has to be defined, which means like up here, I can't have any holes. Okay. Number 2, the limit as x is approaching c does have to exist. Well, here the limit didn't exist, so I can't have that jump, right? The limit has to exist there. And that limit has to equal the value of the function. So basically 1 and 2 have to equal each other, right? The limit has to equal the value of the function. So there can't be this gap in our graph. Okay. in terms of on an open interval, it is continuous in the open interval if it's continuous at every point in the interval, right? If it's continuous from negative infinity to infinity, we call it everywhere continuous. Cool? All right, so again, here's just more graphical ideas of what these are. These are called, if it's got these holes or breaks or gaps, it's called a discontinuity. Well, that makes sense, right? It's not continuous there, so it's a discontinuity, okay? So there's different types of discontinuities. There's what we call a removable discontinuity. That's when you just have a hole. Why is it called a removable one? Because I could literally like plug it with one little hole and I could remove it or not remove it, right? It's like a remove, so that's why it's called a removable one. A non-removable one would be something that has a jump in your graph here, right? That it's not doing the same. I can't just plug in one little point. And so a non-removable would be something like this. This one is removable because, again, I could just plug it in there with that hole, okay? But this would be, so just the difference between removables and non-removables. I'm not going to ask you too much about that, but just kind of so you're aware, there's different kinds of discontinuities. But again, all three of these would be not continuous. All right, so let's use the definition now to apply it to some problems. So it wants us to discuss the continuity of each function at x equals 0. All right, so we're going to kind of go through each of these. Okay. And we're going to talk about the continuity at x equals 0. And we're going to use the definition. So I'm really going to apply the definition. Did I give you the note card with the definition of continuity on it yet? Okay, so that's the other note card. So let me give you it. Oh yeah, here it is. There it is, continuity. Oh, hold on. No, it doesn't have the definition here. Does that have a definition of continuity? There it is. It is on your note card. Thank you. You do have it on your note card. Definition of continuity. There it is. So I'm going to use that definition, and we're just going to go through to prove that something's continuous or not continuous. You're just going to go through step 1, step 2, and step 3. Okay, so here it is on your note card. Okay, so step 1 says f of c is defined. So we're trying to discuss it at x equals 0. That means c is 0 in this case. Okay, so I want to know, is f of 0 defined? Well, if I plug in f of 0, this is number 1, right? Step 1. If I plug in f of 0, what do I get? I get 1 over 0. That's undefined, and I'm already done. Because the number 1 is not working, it's not defined, and so I can say, therefore, not continuous.
So if one doesn't work?
If one doesn't work, you're done.
Okay.
Yeah, you do not have to keep going through all three. Okay? So not continuous at x equals 0. It's continuous other places, so you do want to clarify where you're talking about, because at x equals 0, it's not continuous. If you think of the graph of this function, it's got an asymptote there, right? This is our reciprocal function. Okay? We've got an asymptote at 0, so obviously it's not continuous there. That's a big old break in my graph. Yeah.
Are those 3 dots?
Therefore. That's all it means. You'll get used to it. It's a nice little higher level math term. Okay, so let's try the second one. Okay? This is a piecewise. If you want to draw a graph of it, that will kind of help your brain to see what's going on. It's x plus 1 for all x is less than 0. Okay, so that's x plus 1 less than or equal to 0. Okay, so this would be my graph, right? Less than or equal to 0, so I do have a closed circle there. X squared plus 1 for all x is greater than 0, so that's just a parabola to the right. All right, so we're discussing the continuity at x equals 0. So let's try number 1. Is f of c defined? So number 1 is f of 0 defined. What happens if I plug in a 0 here? What am I going to get? You get 1. Yeah, it would work for this one because that's including 0. So I would plug in a 0. I get 0 plus 1, so I would get 1. So check. Step 1 works. Does step 2 work now? What is the limit as x is approaching 0 of f of x? Well, look at your graph. What's the limit as I'm approaching 0 from the left and from the right?
1.
1. Check. Does number 1 equal number 2? That's all that 3 says. And they do. They're the same number, right? So I would say f of 0 equals the limit. I always do this one backwards. It doesn't matter. But I always do it backwards. This is the other way. It doesn't matter. right? So the value of my function is equal to the limit, check, 1 equals 1. So this would be an example of a function that is continuous at x equals 0. If you look at the graph, it's true. It's continuous. It continues. Now, it's not a straight line or a nice curve, but there's no break. It just keeps going the whole time. And so it does make sense that it would pass every single test. Okay? Ready for C? All right, we've got another function. Very similar to the last one, but this is x squared plus 2. So how's my graph going to look a little different?
It's not continuous.
Yeah, it's not going to be continuous there, right?
Because it jump.
Because there's going to be a little jump. So that first one is still at 1, right? That's the x plus 1 for less than or equal to 0. And then this, though, is at x squared plus 2. So that's up at 2, and that's an open circle. Sorry, pretend that's open. And there's my parabola. So we have this jump, right? So we know it's going to have to not pass the test. But you actually have to show it to me, okay? You can't just be like, oh, look at the graph. It's not continuous, all right? For this could be like a free response question or an AP test. And they would expect you to go through step 1, step 2, step 3, and tell me which one doesn't work. So let's try step 1. What is f of 0? F of 0 is still 1. So that still works. So it's not our issue. We don't have an issue with step 1. Step 2 is that the limit as x approaches 0 is what? What's the limit? Yeah, this is why we all failed that quiz yesterday. What's the limit?
0.
What's the limit? I'm waiting. What's the limit?
Does
There's
not
none.
exist.
Does not exist. Yes, Yaneli. Why does the limit not exist, people? They're approaching different values. From the left, I am approaching 1. From the right, I am approaching 2. That is not a limit. Yeah.
For the first one,
Yeah.
you're just using like the top.
You're using what?
The first version, you're just using the top all the time.
No, not necessarily. So you're using wherever 0 applies. And since this one has 0 included, I'm going to use the top. But if this hadn't included, I would use the bottom.
Okay.
Okay? Yeah.
Wait, why do you only look at the first equation and not the second?
I don't. I just, yeah, you're about to test that. So I only looked at, because I was looking for f of 0. So which one of these two includes 0? In this case, the top one only included 0, so that's why I plugged it in there. Okay. For this one, it doesn't include 0, so I can't plug it in the second one. Good questions, you guys. If it had the include 0 here, I'd plug it in here instead of there. Okay? So since it doesn't exist, that's where I stop. Right? The limit has to exist for number 2. And it doesn't exist, so I would say therefore not continuous. And this is kind of the thing that'll be on your quiz, you guys, okay? So it'll be a question like this, probably piecewise, right? Where you do a graph to kind of back it up and then go through steps 1, step 2, and steps 3. Yeah?
So, do you have to include like the 1, 2, or can you just like randomize the question?
Yeah, I mean, you don't have to technically, but for me it's really nice and easy to go through step 1, step 2, step 3. They kind of make sense too, and they kind of go in order. So I would say just do it, okay? I don't know how like AP test grading would answer that question, but I would say I'd probably do it.
Yeah.
All right, so what do you guys think about this one? All right, nice piecewise. You're getting used to piecewise here, right? X plus 3. Everywhere except at x equals 2. Cool? So it's going to have a hole there.
Oh, it doesn't.
But then what's the value at x equals 2?
0.
0. So that means I do have a dot here. Okay. So looking at the graph, we can say not continuous. There's a hole, right? There's a jump there. There's a break. So we know it's not continuous, but why? Is it step 1 that's our issue? Well, let's see.
No.
No, because f of, we're looking at this at x equals 0, right?
It's 3.
Oh, hold on, you guys. Okay, wait. We're trying to examine at x equals 0, is this function continuous? Not at x equals 2. At x equals 0, is this function continuous? Yeah, at x equals 0, it is continuous. So be careful, okay? At x equals 0, my value is 3. The limit as x approaches 0 of my function, well, what's my limit here? Well, it's just 3. It's approaching 3 from the left, approaching 3 from the right. My limit is still 3. Okay, and so since those two are the same, it is continuous.
So you only use,
No sense.
you only use the equation
with the one that they gave you. So since they only wanted to ask you about it at x equals 0, those were the directions, that's the only one I'm looking at. So I would say, yes, it is continuous at x equals 0. If they had asked you if it was continuous at x equals 2, your answer would have been no. Because at x equals 2, that's where you have that gap. Okay? What's going to happen at x equals 2? You're going to have a value, you're going to have a limit, but the value is not equal to the limit. And that's where you're going to have the no. So it would be a step 3 issue with that one. If that makes sense? Okay.
Wait, how do you know it's where it's supposed to 0?
Because they told you here. They wanted you to examine it at x equals 0. So that's the reason I'm using zeros for my c's and all those. Okay. All right, good. All right, let's keep going. One-sided limits, you guys know this already, right? If it has that little plus on the right-hand side, that means that it's a right-hand limit. A negative has the left-hand limit. If it's negative, it's approaching it from the left. If it's a positive, it's from the right. Okay, in order to have an overall limit, left and right have to equal each other, which you guys know. Okay, so looking at this one, the square root of 4 minus x squared. You guys remember what that graph looks like? Semicircle. Not that one. This is the semicircle graph. The square root of 1 minus x squared. Remember that one?
Yeah, okay.
Maybe, maybe not. Graph it on your calculator. I'll show you. Square root of 4 minus x squared. All right. Yeah, so it's just your semicircle from -2 to 2. Take the square root of 4, right? That's what gives you that. So this wants to know a one-sided limit, -2 to 2. And it's up here at 2. So it wants to know, as I'm approaching -2 from the right. So what's my limit from the right as I'm approaching -2? 0. So my limit there would be 0 because I am approaching a y value of 0 from the right. What if it had asked you the limit as x is approaching -2 from the left of this? From the left, there's nothing over there from the left. So if there's nothing over there, it can't have a limit. And that would be it does not exist.
So why is it 0?
Oh, because I'm looking at what's the y value as I'm approaching it from the right. What y value am I getting closer and closer and closer to? So if I did like numerically, if I did a table numerically and was doing like -1.9, -1.999, -1.9999999, what would I be getting closer and closer to? My y value would be 0. Okay? So therefore, the overall limit here would not exist because they'd be different from both sides. Okay. All right, you guys remember the greatest integer function?
Yeah.
Right? That's the steps, right? So again, if you forgot it, there is a way to do it on your calculator. It's under math, and it's number 5, INT. Under math, number INT means integer. And so that just means greatest integer function. And you'd put in an x there. And then it shows you all your steps. Okay. Open on the left, close on the right. Open on the right, close on the left. I always forget. Help me out. Come
Yeah,
on.
that's
All right, that's how it goes. But which ones are open, which ones closed? Because one of them's open. So let me think about this. At 1, you want the greatest integer that is not greater than 1.
There you go.
Is that right?
I think so.
Somebody check my answer key. I think it's right. All right, so go ahead and figure out from the left, from the right, and then overall. And we're at 0. We're looking at it for 0 here. I'll just double check to make sure. Yes. Okay, good. So we're looking at it as it's approaching 0 from the left. So from the left of 0 is actually down here. So what's the y value as I'm approaching it from the left? -1. So that should be a -1. But as I'm approaching it from the right, what's the y value? 0. And so therefore the overall limit, because I have a different value from the left, a different value from the right, does not exist. Okay, you can't have different values from left and right. Okay. I'm going to pause my video because this is long enough for now. And then we'll go back and do the second part.